Well, we're going to talk about a pre-calculus problem now, where we add vectors that are going in different directions. The vectors are set up so that one vector represents the speed of an airplane with respect to the ground, or with respect to the air, and then the speed of the air with respect to the ground. And we need to combine the two so that we can find out what the airplane, how fast the airplane goes with respect to the ground. Here are the vector quantities set up on a graph. The airplane moves 30 degrees from the north, and the notation for that is that the airplane has a bearing of N30 E, N30 degrees E. And the wind has a bearing of N40 degrees E. Vector-wise, we can say that the vector of the airplane with respect to the ground is equal to the addition of the vector for the airplane itself with respect to the air and the vector of the wind itself with respect to the ground. Now, the only way to do this, the way that you should do this, is to divide the two sets of vectors into their components. The components depend on the direction and the speed. The velocity of the plane, or I should say the speed of the plane, is given as 530 kilometers per hour. And the speed of the wind is given at 20 kilometers per hour. To divide this, we have to say that the speed of the airplane with respect to north is equal to the 530 times the cosine of 30 plus 20 times the cosine of 40, because the angle here is different than the angle of the plane with respect to the ground. And that's going to end up equaling 474 kilometers per hour. The velocity of the plane with respect to the ground to the east is equal to 530 times the sine of 30 plus 20 times the sine of 40. And if we do the calculation here, it ends up being 277 kilometers per hour. And the way you combine these is that you have two sets of normal coordinates. And so you can say that the speed of the airplane totally is equal to the square root of the speed of the airplane with respect to north squared plus the speed of the airplane with respect to east squared. And this quantity is, we take the square root of that, and the answer will come out to be 549.7 kilometers per hour. And that's the way you do the problem. Divide it into components, add the components, take the square root of the sum of the squares of the components, and we come out with the answer. Thank you.